We're covering a lot of ground today. I'm moving pretty fast. I apologize for that, except that, like I said at the outcome, in terms of the objectives that I have for this afternoon, is I really want to give you enough depth and enough breadth to go actually practice this. One of the resources that I'll point to, actually, they ended up putting it up for free, that I highly recommend as a great resource. This was book number 16 I worked on, Huntpedia. It's got basically a who's who of the best cyber hunters out there. And we were all asked to contribute a chapter. I contributed a chapter on using machine learning to assist in cyber threat hunting. But there's just some crazy, so in particular, Chris Sanders, Jack Crook, Rob Lee, David Bianco, Tyler Hudak. I mean, all of the chapters are good, but those handful of folks, David Bianco in particular is kind of considered the father of all of this. I was kind of super fortunate. I spent some time at General Electric, and the team that I was fortunate to be a part of is one of the original teams that kind of put a lot of this together. I'm not taking credit for that. Let me be really clear. People way smarter than me, but I was fortunate enough to be in on the ground floor at some of this. All right, so let's continue on. So we're back on malware-analysis.net, right? We've been going through here, and you saw what I was doing, right, was collecting a whole bunch of interesting things to potentially look for. Now, someone came up, and I apologize, I forgot to ask your name, sir. Eric. Eric came up and pointed out something that was awesome. So if you've looked at as much ATP as some of us have, notice these are all of these URLs are straight off of the root of the server. That in and of itself is extremely unusual. One of the other things that you want to do in these processes is spend some time learning what normal looks like. So far, we've been focusing on what does abnormal look like, and that's critically important, and you probably want to put something like 60, 70% of your initial learning practicing in that. But you also similarly want to spend time looking at normal. And luckily, normal is really easy. Download Wireshark. It's free. Fire it up on your computer and just capture all the traffic going to the internet on your computer. Just let it run in the background. And collect that on an ongoing basis. And what you do then is pull it up. Your screen will look, this is actually a Wireshark screenshot here. And in this case, it's filtering HTTP. But basically, look at what that traffic is. And what you'll get a sense for is how do the browsers interact with real sites on the internet. And as Eric pointed out, in the real world, an endpoint is typically multiple URLs deep, right? So there's something slash something slash something often, right? Rarely beyond your initial connection to the endpoint, to the server, is it a top-level URL like that. And there's a great example of the kind of nuances that become really, really powerful as you grow your skills in understanding what normal and abnormal looks like, right? Because that is a much broader search. When I'm doing hunting in the real world, I actually do this as a multi-stage process. So if I go back to the diagram I showed earlier, If we bring that back up, this gather relevant data, notice here I've got an and clean out to the side. It's an optional step, not necessary. But what I'll do is I'll take the big pile of data, right? I'll start with a huge set of packet captures. And then based upon experience like, well, you know what? I'm going to filter out and just keep the stuff that has single top-level domain, for instance. Throw out the rest. I'll go through a handful of cycles like that to reduce the data set size. And the other thing that I will mention, I do almost all of my hunting in the real world when I'm actually doing this work in Jupyter Notebook using Python. Because pandas, you can create data frames for any type of data easily, categorize it. It's just a phenomenal way to slice and dice the data and kind of get at those components. All right, so we talked about converting the PCAPs. Now there's, I mentioned I had a local config. So this line here, the middle line, extract-all files, that's the optional config I set on my local Zeek copy. That's what caused it to carve out all of those files from the file stream. Completely optional, but super useful, especially for the malicious traffic components. Now, another thing that I didn't do in this case, but I would do again if I was really hunting on this data, is this last config here actually tells Zeek, put it out in JSON instead of in text file format. And that's because, again, typically I'm going to use things like an Elasticsearch repository plus Jupyter Notebook to really do the analytics on this data. And that, of course, just makes it so much easier to ingest into my Elasticsearch or even just to load it straight into a Pandas data frame, right? Making sense so far? Still with me? All right. So then what we end up with are a whole bunch of things, and this is just the tip of the iceberg. I give some examples. At the top, these are obvious things, right? These were the kinds of things we recorded, right? We could look for domains, IP addresses, hashes, URIs, the URIs from the web pages. But they're the really, really sophisticated actors. If you're interested in hunting the really talented folks, the folks that are actually most likely to get past your defenses, you're going to have to rely more on things like content anomalies, things like timing irregularities, or size irregularities, right? So content anomalies, I'll give you an example. One of the Chinese threat actor groups that no longer operates, but was operating about 10 years ago, their exfil tool emulated FTP. So if you looked at it in a packet capture, it looked like you had FTP protocol going on. But they typoed one of the commands. The way the tool actually worked is it would open up a long-lived FTP session, on port 20, right, which is normal for FTP, and then it would receive the commands for that, and then, of course, push the data back as needed, the results of commands to be executed, etc. But because of that little typo in one of their commands, that became a really useful content anomaly that could spot. Other examples of content anomalies would be things like that, the base 64 string in places that it doesn't exist, right? Or anything that isn't normal content is, of course, ultimately a content anomaly. But you'll usually have to get to that level of nuances in order to find the more sophisticated actors. Timing irregularities are things like, if I go back to that FTP example I just gave, right? Normal FTP session tends to be very short-lived. right? You connect to command, right? So if you're not familiar with FTP protocol, it uses 2 ports, 1 port for passing commands and 1 port for passing the actual data, right? 20 and 21. So normally those connections are very quick and just as long as needed to transfer the data. Well, that same exfil tool I just mentioned earlier, it would potentially keep a session going for days. That is not normal timing for a FTP session. If you looked at the sizes of what was being transferred, because it was just basically holding this session open, it wasn't actually transferring much data except when the C2 command and control was active, which showed a whole bunch of size irregularities, again, that you could look for, right? And so think about those sorts of things when you're figuring out what to do. So again, let's do some hands-on. So I'd like you to go over to the malware analysis traffic.net, like I showed, walking through an example. Again, feel free to do this as groups. Go to pick one of the many on here that looks interesting to you and build a list of things to go hunt for. And let's do that for the next, 10 minutes. We'll go till quarter till, maybe slightly longer. And of course, as usual, holler if you've got questions. Happy to help answer, etc. Oh, sure. It's malware-traffic-analysis.net. I would recommend don't actually download anything from it right now, just because you're all working on your machines. And like I said, this is live malware up there, right? And you all remember the password, right? Did everybody find a good one? Who wants to share? What'd you find? What are some of the interesting attributes that you would potentially hunt for? Again, somebody be brave. Share with the larger group.
I feel like I found a lot of malware through email, like a direction of mail into malware.
Yeah.
The suggestion, which is like blocking certain URLs or IPs.
Yeah.
But there has to be a better way to be preemptive against that, right? Because this is more so as a post-mortem.
Yeah. So his question for those are, so many of these threats are via email. Yeah. So statistically, over 96% of all external breaches start with email. Email is the favorite. And the reason for that is really simple. Those emails aren't actually, so if you look at the security vendor space, a lot of the marketing from a lot of security vendors is, we stop O-days, which are zero-day exploits, etc. Okay? I have actually not seen a real breach from an O-day outside of government agency to government agency in something like 5 years. Why? Because think about how sophisticated Mac OS X is, how sophisticated Windows 10 and Server 2018, so on and so forth, right? There are an incredible number of mechanisms in those platforms to stop exploitation, okay? What these are exploiting are our users. Essentially what they're doing is they're tricking the users into running their stuff, right? And no matter how much phishing training and stuff we do, those are important, let me be clear, but those are only going to reduce. I'll give you an example. An organization I worked at one point in my career, we started phishing training, and initially, I got to remember, I think we only had, the first time we ran it, right? So phishing training, you send what looks to be a phish out to employees. If they click on it, they go to an education, right, if they fall for it, to try and help them understand, hey, you were just tricked and here's how you were tricked, right? trying to educate them to not fall for some of these email things. And I want to say it was like I think it was 43% is the number that stuck in my head. So like that means 57%, can't do math this afternoon apparently, 57%, over half, and this was an organization with hundreds of thousands of employees, would fall for the phish and run it. So then we saw that go up consistently, and then it hit 86% and just plateaued. We could not move the needle at that organization. So we dug in. What the heck's going on that we can't get that last 14%? What we found was it was split almost evenly. About half of that, 14%, was new employees who hadn't been through the training yet. You know, when you have a large organization, there's a fair amount of turnover and constant, employees coming and going, right? Okay, makes sense. The other half just didn't care. They had failed every single phishing training. They had et cetera. There was an opportunity to comment about the training after you went to the education. There were some really rude responses in some of that. I'm not a psychologist. That's not my job. But my point really here is ultimately, in that case, so that organization was, several 100,000 employees. 14% of several 100,000 employees is a lot of people willing to click on stuff. And the adversaries understand that. And so this is not me saying don't do phishing training by any stretch. It helps. It really helps. But it only helps so far. There's always going to be, and the adversaries know that. Our users are always going to be our weakest link, which I would suggest is yet another reason why we have to have cyber threat hunting capabilities within our security organizations as part of adequately defending these organizations, right? So that's right. A lot of it delivered by email. Almost all of this stuff you'll find is delivered by email. But you can't just shut off email. It's a critical communications mechanism, right? You can't even just filter particular attachment types, because a lot of the phishes, when you dig in, won't have any attachments. And a lot of the actors are sophisticated enough, if they have links, right? The links are built so that the server, the first time the link is hit, it presents a real legitimate web page, or looking legitimate. And then on subsequent hits, it sends the malicious content. Why? Because most of our organizations use sandboxing technology and things like that, like there's the proof points, the FireEyes, so on and so forth, right? And what happens is they'll take all this incoming email and they'll scan it, and any links, they go out and they check those links. Well, the first time they check it, it comes back clean because the adversaries know it. Or they'll put the actual malicious link 10 down, right? Because there's parameters in those boxes. Think about if every email that came into an organization, even a mid-sized organization, gets tens of thousands or hundreds of thousands of emails every day, right? And so if there's 10 links in each one of those, then what'll happen is there'll be so much delay, the systems, or we'll have to build so many resources to go analyze those that it bogs down. So most of those platforms that I mentioned have a threshold. We'll say only scan the first 3 links. So what do the threat actors do? Well, in the HTML for the email, they'll put 12 links, and the first 11 links will actually not show up in the email, right? The link is in the HTML, so an automated scanner will see the link, but they actually are not shown in the content, right? There's all kinds of techniques using, CSS and stuff like that you can cause links to not actually show. So it tricks the technology, but the user just sees one link, and of course that's what they click. It's not scanned because it's just not effective to scan. I could go on for days, right? These are the sorts of techniques. But how you learn all that is doing what we were just practicing. And that's why, malware analysis-traffic.net is so powerful and why Brad does such a great service. So who else? Who else had an interesting one that they're game to share? Any particular artifacts, like domain names or anything that you thought particularly interesting? Or maybe was there an interesting pattern that you noticed that you thought that kind of was new to you?
I guess one example that I noticed was on the Playstore, where you can still download an APK file from a third-party Play Store, and then when you go there, you'll see 3 apps with the same name, and you don't know which one is the right one. But the sizes are different, right? And then you'll download that because you would have already given permission to download APK from another site,
right?
And then it can just get access to it.
And what is all of that? That's just variations on that same technique, right? It's tricking you as a user in that, right? That reminds me of a technique. One of the chapters in here that David Bianco wrote, he demonstrates a hunting technique for a particular tactic that a lot of adversaries will use is they'll invert a couple letters in an executable name. So one of the most common executable names on Windows is svchost.exe. That's running all of the services within Windows. So a common technique for the adversaries is to name their malware svchost.exe, right? Inverting the C and the V, right? And for us as human beings, you pull up a process list on that Windows host, you're not likely to spot it, right? Chances are you'll just, because our brains are wired for pattern recognition, and we see that, and we'll invert it in our brain, even though it's not inverted. Well, there's algorithms to find that kind of thing specifically that we can use to look for those kinds of techniques. So I just pulled up one. I picked Quackbot here, and I thought it useful to maybe pop through a little bit, because the other thing I would highly recommend in spending some time with looking through these and learning how the malware plays out is the sequences. So earlier I gave this simplified version of we've got the rat running in the laptop. Okay, I said it's Monday morning and my blood level in my caffeine system is, too high, and I fell for it. And just to be fair, some of the actors are so sophisticated that I would absolutely have clicked on the stuff, right? One of the state actors was famous for targeted nuclear researchers and scientists. And so every industry has its conferences, right? And what this group would do is conference would be coming up for nuclear industry. They would go pull the actual agenda from the actual conference and then weaponize it, right? Send that, right? They do social media, right? Most of us use LinkedIn, etc. We talk about where we work, so on and so forth. So they'll spoof it from a colleague because, again, the speakers for these conferences are public, etc. Anything yet to do with academia and research is readily available. If I get one of those, I can't be expected as a user. And I want to make that clear because we also don't want to just blame our users for these things happening, right? At the end of the day, this is why we're all employed in security is to defend. So this one goes into a little more detail on the sequence because there's actually typically multiple steps here. So let's take Fin7 in particular. I mentioned Fin7 earlier. Fin7, for the last about 2.5 years, has been primarily targeting retail and hospitality industry and organizations. Fin7, what they do in terms of this sequence is they typically will target accounts payable employees. So they'll do some research on social media, figure out who employees for accounts payable are. Then they'll do some research to figure out who some of the vendors for the company they're targeting are. Again, this is pretty readily available information. Then they send a fish that contains a fake invoice. They call, as in on the phone, the person they send the fish to in accounts payable and say, hey, this invoice is past due. I don't know what's going on. You know, I'm from company XYZ, which is a legitimate vendor of that company. Can you open, I just emailed it over to you. Can you please open it up and take a look at it? Sure, I'll take a look, right? Because that's your job in accounts payable. Open the email, click, right? They've now got the host. Really difficult to train your users not to fall for that kind of a sequence. But we want to understand what's going on under the hood in those sequences. Well, in that document, if you open up that fake invoice document, you'll find macro, Visual Basic Script macro inside of it. What the Visual Basic Script does is spawns PowerShell. There's all kinds of techniques for running PowerShell on Windows without even calling PowerShell. You can sideload the DLLs. There's all kinds of tricks to this, right? Spawn the PowerShell. PowerShell pulls a loader, an initial file, and does a direct memory inject. Part of the reason why PowerShell is so popular is because PowerShell has the ability to create free memory, load things into that memory space, and then cause a DLL to point to that memory. We call it side loading. So very popular for that. If you want to see how that works in PowerShell, go download PowerShell Empire. It's got all the PowerShell code to do that. Then that in turn, that loader that is now injected, that's what actually pulls down the RAT, the remote access Trojan, and loads the RAT. So notice it was a multi-stage sequence. Why that's really important to gain that level of understanding, and this Quackbot is an example of that, if you walk through, of that multi-stage sequence, is because then as defenders, we can look for that sort of behavior, right? There might be legitimate reasons to run PowerShell out of Word or Excel, but I've yet to run into them. So potentially blocking that is an option. But of course, in context of our class today, that's an incredible thing to hunt for, right? So that sequence of events we can hunt for specifically both at the network layer and at the host layer. Does that make sense? Right? We can look for that specific sequence where, oh, we've got an email, and then shortly after the email, we see, typically a binary come down. If we can ideally combine these with host activity, we'll see PowerShell being spawned or one of the obfuscation techniques for PowerShell. But either way, we end up with a sequence that is very straightforward to go look for. Okay? All right. So let's get back to regularly scheduled programming. Where's my button here? There we go. All right, so we talked about patterns and nuances. You just got a taste for that. Well, then, of course, next step is we go look for it, right? I usually use this kind of a OODA loop personally, but it doesn't have to be this, right? Identify is just search. Use grep. If you've loaded your files into Elasticsearch or something like that, of course, you can do queries for them. If you're loading it in Jupyter Notebook into Pandas data frames, you can write some simple Python code to look for it, etc., right? However you want to go about identifying. And your intent is initially just to find all of the interesting things. So what is it that matches the hypothesis that you formed, right? So we created that hypothesis. We've gathered up our data sources. We've now taken some of the actual activity and put them into specific things to look for. Might be, like I said, any of these. And then we go through and evaluate all of those that we've had. Is this malicious activity? Is this not? And the not is just as powerful as the is. Because the not, and that's why I've got this in a loop, allows us to refine our identification on the fly. So if we see something that isn't actually malicious, why is that? Is that we just want to eliminate looking for this, or is this we want to scope it slightly tighter, right? It all depends on what the data is, but this becomes an iterative process whereby we end up with, at a certain point, almost always something that's malicious. Okay? I already showed this on the gather and clean. Couple examples, right? Here I've got a hypothesis. I've talked about this one as part of my examples, right? So malware masquerading as legitimate, right? This is the user agents that we talked about earlier. Or another example, likes to hide by misspelled. This is the SVC host thing that I was talking about earlier, right? Now for this one, we're going to need host data rather than network data to look for this one. So again, remember back to our hunting process, hypothesis, gather the appropriate data that would have those indications, and then do the analysis to look for that data, right? So, tricks for success. Well, the first one I think you've probably got by now, right? The deeper your understanding of the malicious activity, the tactics and techniques of the adversaries, the more likely you are to be successful at this. I actually keep a hunting log, I call it. So that same notebook I pulled, I have a running, wow, that was interesting. I don't have time to hunt this now, but that looked weird. I want to go dig into that. At this point, my hunting log is something like 40 pages long. One line per item to go look for. I don't think I'll ever get through the whole thing, but it's incredibly useful because now when I get some time to go do hunting, I've got an ongoing list to actually go for. And I'm going to show another resource in just a second to jumpstart this for all of you. Clearly, what we just did was we spent time analyzing some of the malicious activity at malwareanalysis.traffic.net, right? That's this, right? Actually take the malware, run it through your sandbox, collect the attributes of it. The same thing that Brad is doing for us, you can do yourself. Just be careful. See earlier warning, right? Again, I mentioned this in passing too, right? The best results often come from really nuanced. Things like the question Eric posed about, wait a minute, those are all top level. A lot of the really best stuff is really nuanced like that. And you just want to keep that in the back of your mind. This also requires a lot of data analytics skills. So when I was first working, when I started writing the content for this class, I was originally going to do some labs with you using Jupyter Notebook. And I realized that we would spend all of the class time teaching you data analytics instead of hunting. So I pivoted, and that's why I didn't end up including that. But it's really important to understand that hunting is an application of data analytics at the end of the day, right? That's what we're doing, is we're taking the skills from data analytics and applying them to find malicious activity. The better your skills at data preparation, the better your success. I mentioned when I first showed the process, right? Probably the most of the time you'll spend is in the data gathering step. A lot of time will often be spent there. It's similar if you've done any work in data science and machine learning. The more time you spend in prepping your data, the better the results you have when you do your analysis. right? It's the least fun in my opinion, but at the same time, I also realize that spending that time also gets me better at understanding what normal and abnormal is. This is the same reason why I mentioned earlier where I really go through some cycles of cleaning and shrinking that data set in that second phase of the cyber threat hunting process. And then last but not least, on the tricks to success part is I would suggest there are no unsuccessful hunts. Now, I mentioned earlier in upfront story, right, that we had 100% success at finding malicious activity when I used to have a team doing this. You won't, especially starting out, probably find malicious activity. But don't consider that an unsuccessful hunt. Think about the benefits that we started earlier our class with, right? Finding malicious activity is only one of the benefits. The other three benefits of better understanding your environment, growing your skills at being able to find anomalies and interesting things in the environment, and improving your static detection, those can all occur even if you don't find malicious activity. One of the things we actually do on our team at Target is each hunt is led by one of our really experienced incident analysts, right? They're assisted by an entry-level and a mid-level analyst. They're not assisted because the experienced analyst needs the help. They're assisted because it's an incredible opportunity for mentoring and learning. There is almost more value, in my opinion, in the time I have spent personally hunting for being better at able to defend my environments that I work in than the stuff I've actually found. I really, truly look at that as a side benefit at this point. As I've done this more and more and more, I've realized the actual process of hunting and spending this time has absolutely made me much, much better defender. And the icing has just been the malicious activity. And that's why ultimately I'm so passionate and such a proponent of cyber threat hunting in our environments. So, bunch of tools. Again, most of this are pretty, we've used much of these. We, of course, haven't used Jupyter and Elastic. That's what I would really recommend. But again, I was afraid we were going to end up spending too much time getting all of that working and not actually doing. So at this point, I'd like you to hunt. So go out, and hopefully some of you got Zeek installed up front. I sent that as a recommendation. If you go out to these resources, oh, I almost forgot. I mentioned the hunting notebook, and there's a fantastic place for that. So David Bianco and some other folks run a thing, and it'll lead you to a Git repository for it's called the Threat Hunting Project. The link's in the deck that you'll have access to. Each one of these is a hunt. So to start with, I mentioned I keep a notebook, right? So we'll just pick one right? So EMET, log mining, right? So description, other notes. Most of them actually have they've got data required, right? So this is Windows EMET logs. Let me pull another one. There we go. Analyze producer consumer. So what to look for, methods to do it. So if you're not familiar with producer consumer ratio, most normal traffic has you mostly download and just a little bit of upload. So normal interactions with the internet from a host, there's a high ratio of download to a low ratio of upload. interestingly enough, a lot of malware that's inverted. There's a high ratio of upload to a low ratio of download. And so this is a hunt specifically looking for hosts exhibiting that inverted ratio. How to do it in Python. Obviously, it could be ported to all sorts of other languages as well. So this is a great place to start for ideas to go actual hunting in your environment. Okay? And then what I'd like you to do then is the WRCCDC link that I showed you earlier. I'll go back to the links here in just a second so you can see those. Pull down a couple of these, use Zeek to convert them, try looking for the things you just identified in those. Just use grep, right, on the HTTP logs. See if you get anything interesting. You might also just try loading those HTTP logs into Excel if you've got Excel on your, or could be any spreadsheet. Because they're just, the text version, by the way, is just tab delimited text file. So just, you can import it as a tab delimited CSV. So go look for that and see what you get. And I will come around and help. Here's, I'll go to the other link in a second. I want to leave these up. These are highly recommended. And as a kind of a effort to incentivize you to go hunt as your homework coming out of this class, I've got my contact information. The deck's up here on my GitHub, right? I will, over the next month, whoever sends me the most interesting finds from the hunting, I will send you a free copy of Huntpedia, just as an incentive to invest some efforts in that. Here's, again, all the resources. For what it's worth, you can get the PDF for free. So you don't actually have to buy it. But I would sign it if you want. So really go all in for incentive here. But the key here is practice, right? I could spend the entire day giving you examples like I've been doing, and they make for great stories, etc. But all of this happened because I hunted, right? Because I dove in, did the time, did the analytics. That's how you get good at this. And the value of that, truly, I'm hoping I've convinced you, is in the doing. So, last thing I want to ask before cutting you loose on that, and I'll hang around for a while. So here's my objectives. I said at the beginning, how did we do? Gaps? Anything I need to cover I'm missing? It's really, I'm doing this because I love this, and it's a thing that needs to be done, and unfortunately, I find is rarely done. Sir?
In terms of practice, you kind of alluded to it earlier. Are there any potential things some of us could try in terms of our practice that might kind of take us into the illegal area?
Practicing out on data that you don't own, yes. That's the thing is, remember the definition, right, that I gave. In an environment, that was very intentional, right? In my opinion, certainly you could use these techniques out on the wider internet, but that could absolutely cross some legal boundaries.
If you did a Wireshark capture at an airport on Wi-Fi traffic, is that illegal?
That's not a good idea. Yeah, do it. Do it on your own traffic. Do it in your own organization. You won't get into trouble. It's not illegal in your own organization. You might get into trouble if you're accessing data that you're not supposed to be accessing in your organization. So obviously talk to the group. But in my experience, go talk to the network team, right? Say, hey, this is what I'm trying to accomplish, et cetera. I rarely run into problems with people being concerned about that. But maybe that's just because I'm experienced at it. But that's also why I gave you all those resources, right? There is literally on the, so one of those links listed here, right? This site right here, which is in the URLs, there are over 10 terabytes of PCAPs, both malicious and regular open ones, that are all open source. So you can practice and get really good just using these, candidly. So there's no reason to need to take any risk or any exposure to gain these skills in such a way that you don't get in trouble. I'm certainly not advocating for that. We need more people that aren't criminals with these skills. Other questions? Yes, sir.
So this is it's very labor intensive up front.
It is.
So how would you transition from this being like a hobby or fun to do into actual skills that you can bring to a workplace that would actually dedicate time to letting you do this work, which may or may not yield any?
Yeah. Well, the latter is the hardest part of that question. So his question was, so very labor intensive, how do you actually get time to do that, right? That's, of course, ultimately going to vary with each organization. In my experience, most organizations, the leadership has at least heard of cyber threat hunting, and I find very rarely that they're not open to it. Now, they may, like in our case, right, we've got a weekly hunt every week, and we kind of rotate our team members through that hunt process and have some dedicated folks at it. Certainly, you won't necessarily get dedicated. But what you can do, even if you can't get dedicated time, our message to our incident analysts is, if you're not working a case, you should be hunting, right? Hunting isn't something you need to absolutely dedicate time to. Now, it's going to take longer, right? Because you're doing it an hour here or a half hour there or what have you. But you can still gain a lot of those skills in that process. And through that, that's how I would suggest justifying having dedicated hunt resources. Certainly a small organization, that's going to be tough. But an organization of any size really, I would hope has the ability to dedicate. Because here's the thing, like I said earlier, I used to run a team that would do this, right? We never didn't find unknown significant malicious activity. Not once. And we did a couple hundred hunts over, the years I was at that organization. So that's the kind of crazy part, is often we as organizations have this false sense of we don't have a problem because our static prevention detection isn't saying we have a problem. If we don't use methods like hunting to help validate that, it's really problematic. I'm not saying every organization has a breach in progress. That's not what I'm trying to say. A lot of this ends up being very low level. If you actually read like the Verizon data breach report or FireEye's annual breach report, those are really a couple good resources. They've got a statistic in there called dwell time. And essentially, dwell time is a measure of when the adversary got in the environment, when were they detected. That's in the hundreds of days, right? So often there is a big window of opportunity we have to find the adversary before they actually complete whatever their objective is. And again, that's where these techniques and cyber threat hunting. So unfortunately, I don't have a one right answer for the how you justify. It really depends on leadership. But I am game to talk to your leadership and try and help convince them for what it's worth. I am that passionate about this. I do think it's that important. I truly think that the fact that we don't have more skilled cyber threat hunters is one of the real core contributing reasons why we continue to have more breaches every year than not. Because the really capable adversaries like the Fin7s of the world absolutely understand how to evade our prevention and detection. And so if that's all we've got to defend ourselves, then we're essentially playing Russian roulette with our defenses.
So this looks like a pretty interesting skill set, right? So I have just a general question, right? If let's say some of us want to jump into this, like how does the career path look like?
Well, that's the interesting thing. I don't know that there's really very few organizations that have dedicated hunters for a specific career path per se. But here's why I made the earlier statement that I realized that the benefits of all the time I've spent investing in my skill development in hunting have paid so much dividends is because they've taught me data analytics, right? All of that journey, and that can be applied to way beyond just this, right? Any developer or any security role could be benefited by the skills that are part of cyber threat hunting that would make you, skilled at doing cyber threat hunting. So today, I don't know of many organizations that have dedicated. There are dedicated cyber threat hunter roles out there, but there's probably, call it, less than 500. I'm guessing in the world. That's a complete swag on my part. It's certainly not very common for organizations yet to have dedicated threat hunters, but it is certainly growing and will continue to grow. That I'm confident of. But regardless of having a specific threat hunting career option, the skills that you develop for this are applicable for troubleshooting, for reverse engineering, for all sorts of other things that also have career paths available to them. Does that make sense? All right, I think we're almost out of time. One more question maybe? If not, I'm happy to hang around for here a little bit. I don't know when they're kicking us out, probably before too long. Anything we should do to wrap things up, sir? No? My pleasure. Thanks everybody for attending. Hopefully I didn't bore you to tears. Again, contact info here. Like I said, hit me up on LinkedIn. I love to connect. That's the URL for this deck, which has got all those resources. Go practice. Send me some interesting stuff over a LinkedIn message, and whoever does that in the next month, I'll send you a copy of Huntpedia. Thank you.